If we held a free concert for your favorite artist in the stadium, where would you choose to sit? Well, if you got here early enough, probably close to the stage, where the pull of the performance is the strongest. If you got here late, you'd probably end up here, in the nosebleed seats at the very top of the stands. This unit is going to show us how atomic behavior is not so very different than fans at a concert. This is real chem. Key to understanding atoms is appreciating an atom's electron configuration, one of the most important ideas in all of chemistry. An atom's electron configuration is about how we orient the electrons around the nucleus, a bit like how we fill this stadium with fans. In the center of our stadium is our performer. They exert a strong attraction, so our fans want to be as close to the field as possible. As the stadium fills, the first to arrive will go to these seats close to the field. But eventually, this block of seats will be full, and they will have to go and start filling the next block of seats behind. Each successive seating block is further out and higher up, so the fans will need energy to climb the stairwells. The fans won't get to choose where they sit. They will just have to sit in a free block progressively further back and climb more stairs to get there. And so it is with the atom. The nucleus is at the center, and it has a positive charge. So the electrons want to be as close to this positively charged nucleus as possible. As we fill the atom with electrons, the first two electrons go into the first seat block, or subshell, which is close to the nucleus, and so the attraction makes these electrons low energy. When this area is full, the following two go into the next block. This subshell can also hold only 2 electrons. And since this is further out from the nucleus, it has higher energy. And on it goes. For now, we don't need to worry about the names or the unusual shapes of the subshells. We can just think of them as a seat block, with numbers further and further from the stage that take energy to get to. We can even start to think of the periodic table like a seat plan to show us where each element will go. If we add energy to the electrons, such as from a light source, we can also push them into a higher energy configuration, just like giving fans the energy needed to climb the stairs to get to a seating block further back and higher up. If we can find a way to understand how the electrons build around the nucleus, we can understand every reaction, connection, and repulsion in our physical world. Our job is to explore these principles. This unit starts with the wave nature of light and then moves into how this applies to quantum theory and atomic models. Finally, we look at how these principles help to define the periodic properties of the elements. Don't forget to get here early. It's no fun climbing these stairs. This is real chem.